In this research paper titled, Creating Targeted, Interpretable Topic Models with LLM-Generated Text Augmentation, authors Anna Lieb, Manish Arora, and Eni Mustafaraj from Wellesley College explore how large language models like GPT-4 can enhance topic modeling in computational social science. The paper was presented at the 10th International Conference on Computational Social Science in Philadelphia in July 2024. Topic modeling is a common technique used to analyze large amounts of unstructured text data, especially in fields like political science and sociology. Researchers often deal with an abundance of unlabeled data but lack labeled examples, making unsupervised methods like topic modeling essential. These methods help identify hidden patterns in text without the need for extensive human labeling, which can be time-consuming and hard to reproduce. However, traditional topic models have two main drawbacks. They can be difficult to interpret and they're not always practical for answering specific, domain-focused research questions. For instance, when you run a topic model, it might output a list of keywords, but deciding what those keywords mean requires subjective judgment from the researcher. The authors build on previous work to address these issues. In the related work section, they discuss how other researchers have tried to improve topic models. Some have used document embeddings from pre-trained language models like BERT to make the results more meaningful. Others have employed semi-supervised techniques, such as providing keyword seeds or adjusting term weights based on prior knowledge. Additionally, there's growing interest in using large language models for content analysis, like prompting GPT 3.5 to generate topics. But these approaches are often designed for general pattern recognition and don't fully incorporate domain-specific theories from social sciences. The paper points out that while semi-supervised methods can add some domain insights, they rely heavily on researchers to input their own biases or expectations, which might affect the reliability of the results. For example, if a researcher predefines certain keywords, that could skew the outcomes. To overcome these limitations, the authors propose a new method that uses LLM-generated text augmentation. This involves using a large language model to create additional text that adds targeted semantic context and real-world knowledge to the original data. The idea is to feed this augmented text into the topic model instead of the raw, unprocessed text. This way, the model can better capture the nuances needed for specific research questions without requiring researchers to manually specify priors or keywords. This approach is particularly useful for short text documents, like social media posts or news headlines, where context might be limited. By incorporating social science theories indirectly through the LLM's generated content, the method reduces the burden on researchers and improves the reliability of the results. The paper illustrates this method through a case study in political science, focusing on controversies surrounding critical race theory, or CRT, in the United States. CRT debates emerged around September 2020 as part of broader culture war discussions, with conservative figures criticizing anti-racism education in schools and workplaces. For this case study, the researchers analyzed a dataset of over 11,700 online news headlines related to CRT. These headlines were sourced from the GDELT project, which tracks global events through media. The goal was to identify the primary actors mentioned in the news coverage, such as whether CRT is portrayed as a grassroots issue involving everyday people like students, parents, and teachers, or as an elite-driven debate involving politicians, executives, and media pundits. Previous studies in political communications have shown that how media frames an issue can shape public opinions and understandings. So, by applying their LLM-augmented topic modeling technique, the authors aimed to uncover these framing patterns more accurately. In their process, they likely used the LLM to generate descriptive augmentations for the headlines. For example, if a headline mentioned, "Parents protesting school curricula," the LLM might expand it with context like, "Community reactions to anti-racism policies in education," incorporating relevant social science knowledge. This augmented text would then be fed into the topic model to produce more interpretable and targeted results. The authors emphasize that this method allows for exploring domain-specific questions without the pitfalls of traditional approaches. It minimizes researcher supervision, making the process more objective and reproducible. Overall, This work highlights the potential of combining large language models with established techniques like topic modeling to advance computational social science. By making topics more interpretable and aligned with theoretical frameworks, researchers can gain deeper insights into complex social phenomena, such as political debates and public discourse. This could pave the way for more applications in areas like analyzing social media trends or policy discussions, ultimately helping to bridge the gap between machine learning and human-centered research.